Hi everyone and welcome back to the channel. In today's video we are diving into lines that pass through the origin and learning how to work with their equations. We'll tackle two exercises to put this theory into practice. In the first exercise we'll learn how to write the equation of a line passing through the origin and a given point. Then we'll check if other points lie on the same line. In the second exercise, we'll find the equation of a line that passes through the origin and forms a specific angle with the x-axis. By the end of this video, you will have a solid understanding of how to handle these types of equations and apply them to geometric problems on the Cartesian plane. Let's get started. Let's consider a line R that passes through the origin and distinct from the Cartesian axis. We aim to demonstrate that line R represents the set of points where the y-coordinate is proportional to the x-coordinate according to a constant coefficient. To prove this, let's consider two generic points on line R, P and Q. So P, x1, y1, and Q, x2, y2. P' and Q' are the orthogonal projections of P and Q onto the x-axis. So we can draw P' here, and this is point Q'. You can see that the triangles OP'P and OQ'Q are similar. So this is OP'P and this is OQ'Q. The ratio of PP' to OP' is equal to the ratio of QQ' to OQ'. You can also notice that this is x1 and this is y1, this is x2 and this is y2, which means that the y-coordinate is proportional to the x-coordinate. Since P and Q are arbitrary, we can conclude that for all points on the line, the ratio between the y-coordinate and the x-coordinate is constant. This constant is called m. Therefore, we can write the equation of the line as equals m for x different from 0, or y equals mx. This is the equation of a line passing through the origin, where m is called the slope or angular coefficient of the line. This equation is also known as the equation of direct proportionality. Because when x is doubled, tripled, and so on, the y value changes proportionally. You can see it quickly. When x is 0, y is 0. When x is 1, y is m. When x is 2, y is 2m, and so on. Let's apply the concepts we just learned through an exercise. So the goal here is to write the equation of the line R passing through the origin and point P52. So let's draw point P. and this is line R passing through the origin and P. So since R passes through the origin, we know that its equation is y equals mx, and because the line also passes through P, the coordinates of P must satisfy the equation, and therefore we have m equals 2/5. Finally, the equation of the line is this. The second part of the exercise is to verify if points R and Q belong to the line. R is 15, 6, and Q is 27. So we proceed by substituting the coordinates into the equation. In the first case, we find 6 equals, and this is 6 equals 6, which is true, and therefore R lies on the line. In the second case, we find that 7 equals 8, which is false, and therefore the second point Q doesn't lie on R. As a general observation, since a straight line is defined by 2 points, and in this case one of them is the origin, we only need to identify one more point to graph the line. For example, if we choose a point A with an x-coordinate of 1, then its y-coordinate will be m. And this comes, of course, from the equation of the line passing through the origin. Thus, the slope of a line passing through the origin is the y-coordinate of the point on the line where x equals 1. It is clear that as m changes, the slope of the line will vary. Let alpha be the angle formed by line R with the positive x-axis, and this angle represents the counterclockwise rotation from the positive x-axis to line R. So point A, 1m, lies on the line, and if m is greater than 0, point A, 1m is in the first quadrant. And the line passes through the first and third quadrants. So it means that alpha is between 0 and 90 degrees. If m is less than 0, then point A is in the fourth quadrant. In order to do this, let's draw a second line through the origin. Let's call the line R prime. In this case, A will lie on this line, and it is in the fourth quadrant, as you can see. And the line R prime passes through the second and fourth quadrants. And in this case, alpha is between 90 and 180 degrees. There is also a special case. There are two key lines passing through the origin. These lines are defined by specific values of m. So when m equals 1, the equation is y equals x, and this line represents all points where the ordinate equals the abscissa, both in value and in sign. This is the bisector of the first and third quadrants. In this case we have alpha 45 degrees. When m equals minus 1, then the equation is y equals minus x, and this line represents all points where the ordinate equals the abscissa in absolute value but has the opposite sign. This is the bisector of the second and fourth quadrants. And note that here alpha is 135 degrees. Let's put the concepts we just learned into practice with an exercise. Our goal is to write the equation of the line R passing through the origin and tilted at 30 degrees relative to the x-axis. The line has the general equation y equals mx. Let A be the point where x equals 1. The y-coordinate of this point is m. Considering triangle OHA, where O is the origin, H is the projection of A onto the x-axis, and A lies on the line, we can see that OHA is a right triangle, and it is half of an equilateral triangle. You can imagine also this part here. If you remember, for an equilateral triangle, this is 60, this is 60, and this is 60. So this is 30. So we have that OH is 1, and by geometric relationships, OA equals to AH equals to M. Now we can use the Pythagorean theorem and write that OH square equals AH square plus OH square. So this is 4m square equals AH is m, so it will be m square plus 1. This means that m equals plus minus square root of 1/3. But since m is greater than 0, because the line tilts upward, then the slope is m equals square root of 1/3. And finally, the equation of the line is this. Now that we have understood the theory and practiced with some exercises, you should feel more confident working with lines passing through the origin. Thank you for watching this video. I hope it was helpful. If you'd like to learn more about this topic, please let me know in the comments. Keep practicing and see you next time.